Rahmatullah. Now, my name is Shakhzodbek Umurkulov from Fergana State Technical University, and I'm going to share with you my abstract under the name Hydraulic and Numerical Analysis of Non-Uniform and Two-Phase Wastewater Flow in Severe Pipelines. My article is related to civil engineering, and stage, at first stage, I am going to inform a brief information and about my article. This article examines the characteristics of non-uniform and two-phase water-air water flow in severe systems. This non-uniform flow caused by sediment formation and operational condition changes can lead to slight build-up and decreases system efficiency. Uh, I use it I use it to make my article with modern technologies like ANSYS Fluent, and this program is used to simulate two-phase flow with volume of fluid and DPM, discrete phase model, as well as DEKO turbulence model. The results enable visualization of spatial water and air distribution within pipes, evaluate particle behavior of various densities, and determine how pipeline slopes influence flow patterns. In next slide is examined hydraulic analysis of non-uniform water flow. The differential equation for study gradual varied flow in a circular pipe is created by Nikolai Fyodorov. The in the left above side formula is mainly used in different conditions like open flow, open channel flows, hydraulic drives, and turbines, determining the conditions for the formation of a hydraulic jump, and evaluating energy loads in turbulent flow. And I attempt to explain it into conditions. In the first stage, in the first condition or stage, I used this formula in the up to half part of the pipe is filled with water, and in the second stages I used this formula more than half part of the pipe is fulfilled with water, and I try to categorize it, analyzes with different conditions, and for finding the flow depth at the end of a pipeline with diameter is equal 1, and the length of pipe is equal 683 meters, and the slope is equal 0.0006, when discharging Q is equal 723 liters per second. According to analysis and data, that correspondence, the relative critical depth is equal almost 0.5, and the length of the pipeline and degree of pipe filling will decrease from full to critical. If the length of the pipeline is shorter than the specific one, then its filling with will be incomplete. According to information, there are two graphs that contains the large panel on the right and the small inset panel on the left bottom side. This data analyzes the amount, the length of the pipe, slope, and the amount of wastewater per second. The large panel on the right contains horizontal and vertical axes as well as several curved lines. These provide the main relationships between the parameters. And the small one on the left side contains several diagonal lines, and there are also a relationship between parameters such as Q, flow ratio, and alpha as well. And the next slide is demonstrates. Next slide demonstrates several pictures, several figures that and first figure shows the volume of fraction in water, and according to densities, it is they are moved under the part of the pipe under the of liquid or above the liquid, and also there are a velocity that almost equal in the all part of the pipe. And next slide is explained by me, and there are the pipes are equal, but the density of liquid is different from 700 to 1100, and we can show that much more high density of liquid is moved under the part of pipe and with particles and so on, and it is visualized based on the data from DPM model. In conclusions, low density particles predominantly move closer and central and upper part of the flow. At the both inclinations, particles are carried along faster by the main flow with minimal settling. And the density is increased step by step. The high density particles, especially 1,100 kilogram meter cube particles, actively settle at the bottom of the pipe, and this behavior is especially pronounced at the lower inclination. The slope is equal 0.008, where particle clusters and weak flow carry over the observed. To conduct the study allowed for a comprehensive analysis of the characteristics of non-uniform and too-fast wastewater flow in inclined pipelines of severe systems. In the first part of the work, based on classical hydraulic equations, it was shown that non-uniform flow resulting from pressure drops and changes in geometry can lead to the formation of stagnation zones, reduced flow velocity, and consequently sedimentation within the pipes. It was confirmed as accounting for critical depth and the shape of the backwater curve in calculations allow for more accurate determination and information of conditions for stable network operation. In the end of the point of my presentation, I going to inform my full appreciation for you for participating in such high degree conferences, and next time I will try to attempt in such conferences as much as possible.